Soil is truly a complex and beautiful material. It's interwoven with roots and fungi and animals, worms, etc. So the sad thing is that as engineers and scientists, we have to break this beautiful thing down and describe it quantitatively. And it's a real challenge, and it's kind of a fun challenge at that. And so let's talk a little bit about how we're going to describe soils quantitatively while still not doing too much violence to their beautiful nature. What we're going to really start with is breaking the system into phases. And so we're going to start by saying there's a solid phase, a liquid phase, and a gaseous phase. The solid phase we will typically consider to be permanent. And then the liquid and gas phases can trade off. And so we can either have a fully saturated system where all the pore space is occupied by water, or we can have a fully gas-filled system where all the pore space is filled with gas. So we have these three phases that we'll consider. Now, these phases could be considered in two different ways at least. We could consider them in terms of their mass or their volume. So imagine if we are a naive soil scientist, we go to the field with our shovel and we dig a chunk of soil out and we want to know how much water is there. Well, what our perhaps most natural thing to do is to weigh that soil, get the mass of the ensemble of the water and the solid, take it back to our laboratory, stick it in an oven, dry it out, reweigh it, and now we have the mass of the solids alone. And quite immediately, then we have the mass-based split between solids and liquids. We could also then try to identify the volumes of these different components. Why might we want volumes? Well, for example, if I'm a farmer and I know my roots are only 30 centimeters deep, I want to put on the volume or depth of water which will fill that pore space but not exceed it. Do I care what that soil weighs? Not really. I really want to know what the volume of water that'll hold. So now going back to the field, what we would do is take a well-defined volume of soil, maybe in a cylinder, and then we will weigh that and know its volume, and then we'll put it in the oven, get the change of weight, and now we know the change of volume of water, because we can translate weight of water into volume of water, per volume of soil. So we always want to be keeping in mind that we can think about the constituents of our system, either volumetric or mass-based terms. Now, I don't want to leave you with the impression that biology has no impact here, or geochemistry as well. These systems, of course, soils are built up of aggregates. And so all those little pores are actually on assemblages, and those assemblages can take on quite large scale, certainly centimeters. And so we have to be keeping in mind that even though we consider this a homogeneous media, it actually is a multi-scaled media of all different sorts of particle sizes and pore sizes that are influenced not only by the geology but also the biology. This is where the roots and the fungal content can really change the effective pore size at each of these different scales. Furthermore, we can think of our mineral and we think, well, that's very firm and solid, but actually the mineral has an adsorbed layer of water on that mineral surface, and it takes actually on the order of 400 to 600 degrees C to get that water off, depending on the clays involved. And so that's bound water. And so when we say we know the moisture content, we're almost exclusively interested in the unbound water. And so we only put our oven to 105 degrees C so that we don't drive off that hidden water. So even when we talk about water content, it's not quite as simple as it might otherwise be presented. And finally, when we talk about the volume of our solid, we may forget the fact that as that water layer builds up on the clays, it pushes the clays apart. And so what is the volume of our solid? The volume of the solid in a swelling soil is very difficult to define. And so in the case of a swelling soil, we have to report not only the volume dry, but also the volume wet and a swelling curve. So, to put a cap on all this, we do need to be able to describe our complex soils simply. We generally consider there to be three phases: the solid, the liquid, and the gas. We can quantify those either in terms of volumetric or mass-based methods, but we do so humbly, realizing that the system is actually quite complex, and we always move forward thinking about that complexity in case it violates the basic assumptions that we've imposed.